all aware, we are starting, this is your last unit of like new material, new stuff that you haven't seen before. It's going to be kind of like quadratics. We're really short and sweet. Exponentials are going to kind of be like that as well. It's really only 2 new lessons, and then review, and then test. I went ahead and updated when your STAR tests were, so you kind of had an idea. We'll have a few days of STAR review. Prior to that we'll just focus on STAR review, but we're kind of always reviewing, all the time. Especially kind of like quadratics, we'll do a lot of STAR type questions. But this is kind of a weird week with testing and stuff next week happening. So you guys are actually going to be ahead on B-Day. So as far as retests go for quadratics, y'all can come in this week to lunch and knock that out. Like I said, it won't take very long. We can look at your tests, go over anything that you missed. I have first half today and then second half tomorrow. So let's try to get those done, preferably this week. And then, we'll just move forward with our Unit 12 stuff. So that's what we're doing. We will be using Desmos again, so we'll have that in a little bit. But before we do that, we need to talk about what makes a function exponential, kind of some key features. That's too much. And things like that. So this is all different since I was out last week. And let's get going. Okay. So we have talked about exponential. I know we've done exponential regressions. However, we haven't really looked at graphs and what those graphs look like. So today's going to be kind of prioritizing the graphs. We're going to talk about domain and range again. We're going to talk about intercepts. There's another vocabulary word that we have with exponentials that we haven't had yet. And then next class is going to be more about word problems with these, because they have a specific setup with that. But they're not anything super crazy. But here's your first thing is that, how do you know it's an exponential function? So they'll be in this form. A times B to the x. The giveaway that it's an exponential is that x is your exponent. A lot of times I'll write it like this. Exponential. So I can know that anytime x, my variable, happens to be kind of up, superscript like that, that tells me it's going to be an exponential function. Typically, the way these are set up, a and b, just like with quadratics, those will be numbers. Okay, so it could be like 2 times 1/3 to the x, something like that. Your a value is what we know as our initial value, which is usually your y-intercept, also known as starting value. That will help with next class when we get to the word problem. So that front number, it's not attached to the exponent. It's always just the very first thing, okay? So that's going to be your y-intercept. I think he found them. Your b value, this is what is attached to the exponent. It's typically in parentheses. Doesn't have to be, but your b value is your growth or decay factor. And I sometimes call that a multiplier. Because what happens with exponentials is the pattern is that you're multiplying by something over and over and over again. So these real world scenarios that we'll kind of see more next class would be like if you're talking about, a population is doubling. It's going to be multiplying by 2 each time. And so that 2 would be your base. If that b value is greater than 1, then that means that your graph is going to be growing. Okay, so that makes sense. You're multiplying by a number that's bigger than 1. 2, 2.5, 3, 4, things like that. That'll indicate that it's growth. If it's less than 1, that will mean it's going to be decay, which means it's decreasing. It's getting smaller. So we should be able to tell if we have the equation based on that base, whether or not our graph's going to be going up or down. And then here's the thing that's really specific to exponential functions that's kind of weird, okay? And it's on a graph. You can kind of see it right here on this graph that I'm pointing to, how it kind of has that dashed line. Each of these graphs kind of have a line that the graph levels off towards, okay? It's not ever going to cross it. It's not going to land on it. And it's not really on the graph. A lot of times we draw it in dashed like that. But what that's called is an asymptote, okay? And it's spelled kind of weird. ASYMPTOTE, asymptote. And it's a boundary line that your graph gets really, really close to, but does not ever touch. Okay? So it's just like, hey, my graph is leveling off towards that. We typically draw it in with a dashed line. With exponentials, it's horizontal. And this is the only function that you'll see in Algebra 1. So you don't really have to memorize that it's horizontal, like you won't be comparing them. But in Algebra 2, there are other functions that have other types of asymptotes. So you will see it again. Because it is a line, it's written as an equation. And that equation will be y equals, and it's going to equal a specific number. Okay, so that's how you're going to have to write it. Kind of like with axis of symmetry, we wrote it as x equals a number. Your asymptote will always be y equals a number. Sorry, I'm still coughing so much.
So obviously that HA stands for horizontal asymptote, right?
Mm-hmm.
Okay.
And so a lot of times in Algebra 2, to help them keep straight with it, whether it's x equals or y equals, I'll say, hey, and we'll be like, horizontal asymptote, it's got to be y equals. And then it will just be whatever number that is there. Okay? So a big part of this is, can you take a picture and identify all the stuff from here? So we're going to try that on a couple graphs here. These first two, we need to put arrows on them. Oop.
And this has arrows, which tells us it's going forever. Okay?
Negative infinity.
And we use the x, like we talked about, it's the x values to positive infinity, right?
And so kind of like with quadratics, again, if there are those arrows, which as most of the time there is, that is going to be your domain. Negative infinity, less than x, less than positive infinity. How else can you write that?
All real numbers.
All real numbers. You can do that line R. You can write out all real numbers. All of those are okay. Now, when we need to tell if it's growth or decay, we read our graph left to right, okay? So if I start at the left, which way is my graph going? Is it increasing or is it decreasing?
Increasing.
So I would say this is going to be growth. So that would mean my base has to be a number bigger than 1. I don't know what it is. They didn't give me an equation, but I can make that determination based on how it's going. You have to read it left to right, okay? Now, I actually would do the asymptote before I talk about the range. So the asymptote, again, it's got to be written as y equals. So every single time you see asymptote, and they will trick you, they will put answer choices with x equals. You got to remember, hey, horizontal, it's got to be y equals. And we need to find that boundary line that our graph is leveling off towards. So what y value am I kind of drawing over right here?
-3.
So I would say y equals -3. Now, I did that before range because this is going to help me figure out what my range is. It's similar to how we did quadratics, but it's also a little bit different because we're never ever going to land on that asymptote. But the asymptote is a boundary. So what variable are we talking about with range? Y. Every time. No matter what type of function you have, range should always be talking about y. Now, it goes bottom boundary to top boundary. Do I have a bottom boundary on this graph? Yes. At that HA, it's at -3. But will I ever land on that HA or cross it? So I will never equal it. I do not put an equal to line. With quadratics, we always would put an equal to line right there. Not with exponentials. You won't equal it. Okay? Where's my upper boundary? Do I have one?
No.
Because where's the arrow pointing? So that implies it's going to infinity. Okay? Again, sometimes there's a shorthand that I feel like if they were doing multiple choice, this is technically correct, but they would probably write it like this. Range is talking about y. My boundary is at my HA, which is -3. And then I ask myself, is my graph going greater than -3 or less than? Is it above or is it below? It's greater because the graph is above. So this is how I feel like they would probably write it on a multiple choice question, like that. And as long as you know that that number is always going to come from that HA. Does that make sense?
Probably on one of the multiple choice, they'll say greater than or equal to. They might throw that in there, so that should be a good indicator of, hey, it's not that one, because it's not going to be equal to.
Wait, but this one infinity, it doesn't have arrows like on the actual paper.
This one?
No, the ones to the left.
This one?
The arrows aren't so.
I know. We put them on. Sometimes when we grab graphs from the
For
internet.
some reason, it doesn't take the arrows.
But really the only time you wouldn't have arrows is if it was like a story, which there's not really a whole lot of stories with these, or if there was like actual endpoints. Like that's when I've seen it. They would put like open or closed circles. The y-intercept, this graph is kind of hard to tell, but my y-intercept, I'm not quite going to get to -3, so we'll just say it's about -2.9. This one isn't very clear. They should be pretty clear on the ones that I ask you, okay? But that's, again, your y-intercept, it's the point where x is 0, the point that it crosses the y-axis. Okay? Let's do one more together, and then we'll see if you can do the bottom two on your own. Go ahead and give this one arrows here, because, again, that's our bad. They should have arrows. So now, when we read this, we go left to right, okay? So which way? Follow my finger. Which way are we going?
Down.
So we are growing or decaying?
Okay.
We're decaying, okay? Our domain, we put those arrows on there. So what does that mean our domain is?
It could be infinity.
All real numbers, aka -infinity to +infinity. And what goes in the middle, because it's domain? Very good. Y'all have to have that like drilled into your head, okay? Until April 23rd. Really forever, but especially until April 23rd.
What's April 23rd?
Your STAR test. Okay? All right, let's actually do the asymptote first. So, it's a horizontal asymptote. How do I have to write it?
You gotta write it correctly.
Y equals, no, hey. Hey. Okay? And so where is your graph? I drew it in. If you didn't draw it in already, go ahead and do what I did right here in blue. You can kind of see where this boomerang shape is leveling off towards. What y value is it going close to? +2. Very good.
Steven, that's my word.
So I'd write that first.
Wait, but it does touch
No, it's so
+2,
full.
right?
Hold on. Shh. What?
But it does touch +2, right? Am I bugging?
It won't. It gets really, really close, but it won't.
Wait, the solid line?
Bro, man, just
What?
drink your ice cream.
Okay, shh. Please stop. I'm trying to understand where he's confused. What are you confused about?
Was it like the solid line or the dotted line?
So the solid line is the exponential, okay? The dashed line I drew in where the solid line is kind of leveling off towards. And sometimes it really looks like it will land on it, but it will not, in fact. It's just getting super, super close. And once we get an equation, I'll show you with a table how it gets really close, okay? But I like to draw in the dashed line myself to kind of help me figure out exactly where it is. So it's at y equals 2. So now that I know that, I'm able to do the range, okay? Let's do the shorthand way. What value is range talking about, x or y? Y, okay? What is the specific boundary? What y value are we bounded at? Where is the asymptote? 2. So I'm going to leave a space and put a 2, okay? That's how you set it up. Y because it's range, HA because that's the boundary. Now look at the graph. Is your graph going greater than 2 or less than 2?
Less than 2.
Because the graph is under. So I'm just going to put a less than sign. We will not equal it because we won't land on that asymptote.
Awesome sauce.
And then the y-intercept, this one's pretty clear. What's our y-intercept? 0, 0.
What would you ever say?
Okay? All right. On this third graph, the only thing I'm going to help you with is where the asymptote is. Okay? Here's your curve. Where does it look like your graph is leveling off towards? Can you draw it in? Draw in a line.
Is going
Oh dear.
Actually, I don't know where to go.
0.
Follow the end. It's either going to be like far to the right or far to the left.
Oh my God.
So kind of start where it's leveling off and work backwards from there. So what y value did we draw through? 0. So our asymptote is y equals 0. Okay? All right, do these real quick.
I understand.
Okay, let's talk about this graph right here. Is this graph growing or decaying?
Decay.
It's decaying, because if I read it left to right, the values of y are decreasing. Are there arrows on this graph, left and right?
Yes.
So what does that tell you about your domain?
It's
All real numbers.
All real numbers, negative infinity to positive infinity. Any of those are okay. The asymptote is at 0. Now here's something that gets a little bit tricky with exponentials in particular, and it has to do with the range. Although the y values are decreasing, that does not mean we're going to use a less than. Range is saying what types of y values do you have. So we're talking about y because it's range. Our boundary is at 0 because that's our HA. Now the question is, are your y values of this graph bigger than 0 or smaller than 0? So even though they're getting smaller as they go, are they still greater than or less than? 0. They're still greater than. They're still happening above. Pick some. This one's close to 8. This one's close to 6. This one's at 5. This one's at 3 something. Okay, those are all values that are in fact bigger than 0, even though the graph is decaying. So growth and decay doesn't really have to do with the less than or greater than. It's where are the numbers. Okay, so if your range, look, check your range. Check your range. Make sure it's right. It will never equal 0 because we're not going to land on that HA. What's the y-intercept?
0, 5.
0, 5. Thank you. Okay. All right, this graph, growth or decay?
Growth.
Growth.
Too easy. Stop playing.
Domain?
All real numbers.
All real numbers. We'll do the range.
Y is greater than 0.
That's correct. Very good. It's greater than because the graph's above. Where's your asymptote on this graph?
0.
How do you write that?
Y equals 0.
Y equals 0. Okay, you can draw it in. And then our y-intercept is about 0, 2.5. Very good. So a big part of this is going to be interpreting these features from a graph. Okay? Now, flip over. Go ahead and fill this part in again.
No. I already forgot all of them.
Well, it's on the other page.
Womp womp.
Y-I-N-T.
So it's the same types of questions. However, do you have a graph on this page? What page are we on? I don't even know. Okay? We don't have a graph. We just have an equation. Okay? All right, so let's talk about this equation right here. Y equals 2 times 2 to the x. Which one is your A?
2.
2. Okay? And A means your starting amount. Okay? Which one is your B?
2.
Also 2. How do you know that B is 2? Oops. B is not B. B is 2. Because what is that 2 attached to? The exponent. The exponent. That's what your base is. So remember what we said up here. If our B value is greater than 1, is 2 greater than 1?
Yes.
So would this be growth or decay?
It'd be growth.
This is going to be growth. I know that just from knowing what that base is right there. Now, I can confirm this by putting this equation in Desmos. So let's go ahead and put this in Desmos.
I'm about to throw it.
So we've got y equals, not there, y equals 2, parentheses 2, to the x. Hey, I need to make sure you know how to type this.
Do I have to put the parentheses X?
What this?
Yes. And it has to be shift 6. You have to get x as the exponent or else it will not be an exponential curve. Okay? So now we've made a graph. Now we can see what's going on. I also want you to grab your calculator and put this in y equals in your calculator screen. Just so you can see that Desmos is great. The calculator is great as well. 2 to the x. I need to make sure you know how to type in both. The same equation, the same y equals.
First clear. 2 parentheses 2 close parentheses.
And make sure x is an exponent. You should be doing the little caret.
You can graph.
And then I go on
Look like
to
what she does.
You can hit graph and look at the graph, or you could also look at the table.
oh, yes, I see the graph is going up.
It's very
Looks
similar.
like I did something wrong, guys.
Okay, so I want you to have the graph that's on my screen. Second, it's supposed to be to the x.
Oh.
Okay? All right, so can we confirm that this is going to be exponential growth from this graph or this graph? Which way is our graph going?
Up.
Up, okay? So again, that confirms the base was 2. 2 is greater than 1. It's got to be growth, okay? All right, do we know any sort of story about this graph at all?
It goes up.
Any sort of word problem? No. It's just an equation. So what do we assume the domain's got to be?
All real numbers.
All real numbers. You can do that symbol. Negative infinity, positive infinity, whatever.
I draw.
Okay, let's do the asymptote first. It's exponential. It's got to have a horizontal asymptote. It has to be written as y equals. Okay? So either look at your calculator screen or look at Desmos. Where does this graph seem to be leveling off?
Around.
Do y'all see how my mouse is pointing at it? No, what y value?
Oh.
Oh, 0.
0. So this is going to be y equals 0. Again, and y'all, that's pretty common that it's going to be at 0. So y equals 0. Now, Roman, I said I would show you on your calculator here. If y'all go to, you'll have your equation and y equals, okay? Go to the table real quick. How do you get to the table and y equals?
Second graph.
Second graph.
Second graph.
Okay? And I want you to look. What's a y-intercept, first of all? Let's do that first thing.
2.
Order pair.
That was not
What's the order pair? How do y'all find a y-intercept in the table?
0, 2.
Where x is 0. 0, comma 2. Okay? So go to the y-intercept on the table. Of course, it's right here too.
On the star test, do we have Desmos?
Yeah. You have Desmos and a graphing calculator.
Yes.
Which is like,
we started using it. We
huge.
found out you can do Desmos. So.
yeah. It takes you to this exact one too.
That's nice because it tells you.
It is super nice. So as far as graphing, anytime you need to graph something, I would probably go in Desmos. But any like stat, tables, I would use the calculator. If they want like specific values, sometimes I think the calculator is helpful because you have the table. So it just kind of depends on what they're asking. Okay, is everyone looking at the point 0, 2 in the table? Yes? Are you looking at your table and your calculator? Okay. All right, so Roman, here's the question you're asking about earlier. As you start going negative, okay, when x is -1, what's y? Y'all read the table for me.
I don't even know.
Look at it. It should be in front of you. You don't need to look at mine. -1, what does it say right next to it?
Positive.
Look at yours. You can't see my numbers. They're too small. Okay, what about -2? Where's the y value at -2? Anyone?
0.5.
0.5. What about -3? Where's the y value? 0.25. What are we getting closer and closer to as I move more negative?
0.
We're getting closer and closer to 0. If you look at those y values, 0.0313, 0.0156, 0.0078. They're getting really, really close to zero as you move up, and that's showing you what your asymptote is right there. Okay? That's what you're getting close to as you get further and further from x. So if you're not sure, you could go to the table and look that way. Does that make sense? Yes, Noah?
How do I figure out the table?
Second graph. Do you have your equation in y equals?
This one.
Oh, stat. Okay, so the range, let's go back here. What is our range going to be for this graph?
Y equals 0?
It's not going to be equals. It's going to be greater than or less than 0.
Greater than. Because
Why?
it's growth.
Because the graph is,
Growth thing.
no, it doesn't have to do with growth or decay. Because the graph is above the HA.
Y.
Okay?
It's sending letters. They don't think it's right.
No, I think it actually is. Is it ease? Type this one in Desmos. Type it in Desmos. Go.
How do I do this?
How do you do like the table?
Yeah, how would I like
We ain't got to that.
We're not there. Can y'all chill? 1/2 to the x plus 4. Okay, we should be typing in our calculator and typing in Desmos.
Arrow over. Plus 4, is that what that was? Yeah, plus 4. And you can graph it. Is it growth or decay?
Oops.
All real numbers.
Yep. Going down that. So what's the domain? Go ahead and fill that out. It's the same as what it always is.
Okay. Remember, you can kind of scroll around in here if you need to. You can zoom in, zoom out.
It's looking terrible.
Oh my god.
Your hair looks horrible.
So here's your graph in Desmos.
2, 3.
And then we're going to answer these questions based off of our graph. Okay, this go around. Is our graph growing or decaying? Decaying. If you look at the graph, it's decreasing. Also, what's the base? What's the b value in this equation?
It's not 0.
Do y'all know? What's attached to the exponent? Remember, your base is in parentheses, so what's attached to the exponent here? 1/2. Is 1/2 greater than 1 or less than 1? So, since my b value is less than 1, this has got to be decay. Okay? And then, again, we can see it in the graph in our calculator, or we can see it in our graph in Desmos. We can see the graphs going down, so it's decay. No story with this, no word problem, so we assume this graph has arrows. So our domain is, let's do it this way. What's the left boundary? Negative infinity. What's the right boundary? And what variable did I put in the middle? Because it's domain x. Okay? What about the asymptote here? Let's go to Desmos. Where does it look like we're leveling off towards? Y value of 4. Steven's right. Y value of 4. Do y'all see that? In the table, if you go to second graph, this time, as your x values get bigger, you'll start to get, well, those are fractions, so that doesn't really help. But you're going to start to get closer and closer to a y value of 4. So our HA is y equals 4. Do y'all see that number in the equation at all? Where is it, Emma? At the end. So this is kind of another little helpful hint right here. If you have a number that's added or subtracted after that a times b to the x, that number is your horizontal asymptote. So since I didn't have a number on this graph, what number represents nothing?
0.
0. And what was our HA here? 0. So if there's a number at the end, that's going to take your graph and it's going to move it, and that's going to change what your asymptote is. To be honest, I feel like most of the STAR questions I see, your HA is at 0. However, it is possible to shift that graph around and move it, and it would just kind of change up some other things. But that's where that comes from. Now, your y-intercept, though, if your HA is not at 0, your y-intercept is not the front number. Did y'all see on this one how this was the front number? Here, whoop, like that. That doesn't work that way here. What's our y-intercept from this graph? What does Desmond say? What's our y-intercept there? Order pair. 0, 5. Okay?
Roman, what do you mean, what?
Okay. Even though this graph is decaying, what is our range still going to be? How do I start it? Range has to do with y.
Greater than?
Is it above or below?
Above 4?
It's a
Yes, it is.
yes, it is. And 4 is our HA. Very good, Stephen. I don't know what I clicked. Go away. There we go. So a graph is still above 4, even though our y values are decreasing. Those numbers are still greater than that there. So what I need you to be able to do, given a graph, given an equation, I need you to be able to define these attributes using Desmos or graphing calculator. Easy? Easy? Okay? All right, let's talk about the table. Do we have a graph on this? Do we have a graph or an equation on this problem? Look, we have a table. That's it. Okay? What do we do? This is good STAR review right here. What do we do if all we have is a table? Put it in stat.
Zero for exponential regression.
Very good. Okay. Get your graphing calculator out. If you don't remember how to do this, this is something. I was tutoring yesterday someone for STAR tests. I said, if you don't press stat probably 10 to 15 times on your STAR test, not going to go well. Okay? All right. So we have to put the table in. So stat edit. Stat enter.
Stat.
What goes in L1?
0, 1, 2, 3.
Your X's. 0, 1, 2, 3. What goes in L2?
Our Y's.
5, 15, 45, 135.
135, that's how much I spot.
Okay? Any time, I want you to listen to what I'm saying. Shh. On your STAR test, anytime there is a table, anytime they give you multiple points, put the points in stat. Now, 90% of the time, the question is going to tell you it's linear, it's quadratic, or it's exponential. This one doesn't tell us, but we're doing exponentials, so we're going to do exponentials. So stat edit, you put L1 and L2. You might want to write this down if you don't remember these steps. And then you're going to do stat, you're going to calculate, and we're going to choose what number?
0.
What's next to 0 on the screen? It says EXPREG. That stands for exponential regression. Calc.
Calc. C-A.
See how up here, Stephen, it says calc at the top of your screen? You scroll to calc.
See, forgot.
And then if you forget, just scroll until you see EXP. It's right there at 0.
Hey, it says error dimension mismatch.
That is a table issue.
Roman.
Okay, so what does your calculator tell you from here? What is your A value?
My A is 5.
5. What is your b value? 3. Do y'all have r squareds and r's on there?
Yeah.
If you do, it's fine. If you don't, also fine. This is all you guys really, really need, is your a and your b. Okay? Now, we have to write this as an exponential. So what does that look like? Y equals,
Y equals.
what goes in the front? A, which is, what goes in parentheses? B, which is, and where does your x go? The exponent. Hey, make sure y'all know how to write it. Exponential will look like this. 5, a value in front, b value in parentheses, x is the exponent. It tells you right here. Okay? All right, now you've got an equation. So what do you put it in? Calculator or? All right, go. Answer the rest of the questions. Your Chromebook screens, real quick. Okay? Okay.
Almost beat Canvas.
Hey, we're not.
Hey,
So if we have a table, we don't have an equation, we don't have a graph, but we have a table. What are we going to do to get an equation?
I know.
Stat.
Edit. Calc. Wait.
Yes.
Stat again.
Yes.
Then calc.
Then
0.
0.
Enter.
Very good. Okay? And then we have an equation we can put in Desmos. Was this graph growth or decay?
It was growth. Yeah, I remember.
It was growth. What's the base? What was your b value here? I need y'all to know that. The base is the one in the parentheses. So our base was 3. 3 is greater than 1, therefore it's growth. Okay? What was the domain?
All real numbers.
All real numbers. Negative infinity to positive infinity. All those things are okay there. What was your range?
I know. Y.
Keon.
Y greater than 0.
Y greater than 0. What was your asymptote, Jaden? Your asymptote on this problem?
Y equals 0.
Y equals 0. Ariana, what's the y-intercept? 0, 5. Okay? Do y'all know where the y-intercept in the equation is?
What you said? What?
The y-intercept is in the table right here. It's on Desmos, but y'all know where it is in the equation.
Oh, yeah.
Yeah.
It's on the graph.
It's the.
You gotta go
it's
all the
the
way
A.
down and it says 0.
It's the what?
A.
It's the a value.
Yeah.
That's just a coincidence.
As long as your asymptote 0, your a value is your y-intercept every time.
Wait, but
Oh, wait,
why
I'm-
is it
oh,
not
never
like
mind.
that on the second?
Because
So you get
what's the?
Because it's put second.
Because it's the asymptote is not at 0 on the second one.
When
So
it's at 0, then.
correct.
When
Okay.
it's not, then it might be different.
Exactly. Okay, last one. This is a star question. We're going to take a quick break, and then we're going to do some more star questions. Okay. An exponential is graphed on the grid. Hey. This is like that last section on quadratic tests, and some of you guys need to retest this. These should be easy questions. Okay? First thing. I have 4 answer choices. Which way is my graph going? Growth or decay?
Decaying.
It's decaying. So I would make a note right here that this is decay. Because the graph is decreasing. If it's decay, does your b value need to be greater than 1 or less than 1?
Brandon.
It's less than.
It's decay.
If it's decaying, your b value needs to
You
be
said it had to be greater.
less than 1. We're talking about 2 different things. You're thinking about range. I'm talking about the base. So let's look at our first answer choice. What is the base on our first answer choice?
0.25.
No, your base is attached to the exponent. I just underlined it. 0.25. Is that less than 1? So is this a possibility? Yes. What about your next base? 0.05. 0.5. Is that less than 1? It's a possibility. The third case, 1.25. Is that greater than 1?
No.
Sorry.
Is that greater than 1?
It's greater than 1, yes. So is that going to be a possibility? No, that would be a growth. What's the last base?
Last base is not the S.
What is the last base record? What's the last base? What's attached to the exponent? Answer choice D. 25. That's bigger than 1. That's way bigger than 1.
One is bigger than B.
So could that be our possible answer?
It's A.
How is what?
Just A, no, what's up?
What are you saying? So now put your 2 leftovers in Desmos and find which one matches. Go. Yes. You didn't hear the answer to the last question was A?
I told y'all.
Again, just like with quadratics, a lot of these questions can be easily matched by putting your equations in Desmos. Okay, we're going to switch gears. We have more exponentials to do next class. Put your computers away. More exponentials to do next class, but in the meantime, I'm going to open up last year's